Hi everyone. Welcome back to our sixth lecture of this book and second lecture of the chapter Overview of Patterns. So in the previous lecture, we understood how write-ahead logs helps us implement transaction in the database and let us keep maintaining the consistency as well as atomicity in our transactions or in our operations that we are doing. So that's a good thing for when we have a single server, but when it comes to like multiple servers, we have different kind of problems. So today we are going to understand a new concept called competing updates, like what happens when multiple consecutive requests happen at the same time trying to update the same thing. In that case, how the database is handled through them. So it is going to be a bit of in-depth lecture, so let's make sure that we are having like full concentration over the lecture. So suppose you have two different users, Alice and Bob. They are trying to connect to two different cluster nodes to execute their request. So Alice wants to move 30 widgets from Boston to London, while Bob wants to move 40 widgets from Boston to Pune. So basically both of them are trying to move data from Boston. So we have a competing update problem here. How should the cluster now resolve this? We can't have just one cluster deciding, okay, I want to update this thing first, and second cluster decide, okay, I want to do this thing first. In that case, we can quickly run into an inconsistency hell. So one of the very most straightforward approach in this situation is leader and follower approach, where one of the nodes is are marked as a leader, and all the others are considered as their followers. In that situation, the leader handles all the updates and then broadcasts them to their followers, and then they gets updated. So let's say Neptune is the leader in this cluster, then Jupiter will forward ILS A1 request to Neptune. So leader handling all the updates here. So Neptune is marked as a leader. So Neptune now get both the update request, and then it will decide, okay, how I want to deal with them. So it will process the first one it receives. So let's suppose a B1 came at the very first. So it will process that first, and it will reject the A1 saying, okay, we don't have enough, insufficient widgets, because we had total widgets of 50, and both of them are trying to move the widgets from Boston to other places. So in the B1 operation, we moved 40 widgets from Boston to Pune. So now we are left with just 10. So we can't actually do the ILS request, which is moving 40 from Boston to other place, London. So we'll give the error to our A1 ILS request and say, okay, we can't handle this request. Now let's suppose we have to deal with a situation where our leader is failing. So what happens in that case, right? So when everything is going fine, Neptune will receive the data and replicates it to both their followers, Jupiter and Saturn. Now everyone is in sync and Neptune is a leader. Life is going very good. But what happens when things go wrong? So Neptune tries to replicate to Jupiter and Saturn, but it can't reach Saturn for some reason. Okay, so it only manages to talk to Jupiter. Then Neptune itself loses the connection completely. Now you're left with just Jupiter and Saturn, which are connected to each other but not to the leader, which is Neptune, which is missing. So now we have a problem. How do Saturn and Jupiter even know that Neptune is gone? Neptune can't even send, hey, I am offline, because it is offline. So how will solve this issue? So the solution for that is heartbeats. So what happens? Each node regularly sends a tiny ping saying, "Hey, I'm alive." We call it heartbeats to all their other nodes. So if Saturn doesn't get the heartbeat from Neptune for a while, it assumes that the Neptune is dead now. Since Neptune was the leader, Saturn says we need a new leader now. So we'll start an election. So basically, in simple terms, if we say nodes keep checking each others with their small signals called heartbeats, and if the nodes stop hearing from its leader, it assumes that the leader is dead, and now we need a new leader for that. Now there is another kind of problem that we have is what happens when Neptune crashes with pending updates. So suppose that Bob sends request B1, okay, and Ilis sends request update A1. So Neptune processes them and replicates both of them to Jupiter, but Neptune can't reach Saturn. So Saturn doesn't have A1 or B1 data. Suddenly, Neptune crashes. Now we have got a split. So now Jupiter has two data, which is A1 data as well as B1 data, while Saturn doesn't have anything. So when the election happens, the cluster will choose which one has more latest data. So in this case, you can see the like Jupiter has the most updated entries A1 and B1. So Jupiter will become the new leader, and then Jupiter will then the Jupiter will share their logs to the Saturn, and Saturn will realize, okay, I'm behind. So Saturn will copies all the Jupiter's missing log entries into them. Now both of them got the same state as before. So this way, even after Neptune died midway, the cluster was able to heal himself by using the logs that we had. So this is all we had for now. In the next lecture, we'll understand what is the bigger problem that we have after this.